We want to find the point at which the line given by the vectored valued function intersects the yz plane. Let's first write the line as a set of parametric equations. Notice how we'd have x of t equals 6 plus negative 8t, or 6 minus 8t. We'd have y of t equals negative 3 plus negative 6t, or negative 3 minus 6t. And we'd have z of t equals negative 2 plus 2t. Before we find the point of intersection, though, let's look at this graphically. The line is graphed in blue, and the yz plane is graphed in yellow. We're looking for the point of intersection of the line in the plane, which should be this red point here. The key to understanding how to approach this is to recognize that every point in the yz plane would have an x-coordinate of 0. So going back to our question, because the point of intersection is in the yz plane, we know the x-coordinate of the point of intersection must be 0. For additional information, I've also included the equations of the coordinate planes. Again, notice how the equation of the yz plane is x equals 0, which once again is why we know the x-coordinate must be 0. And now to find the y and z coordinates, we'll determine what value of t makes x of t equal to 0, and then we'll use that value of t to determine the y and z coordinates. So for the next step, we'll set x of t equal to 0. So if x of t is equal to 0 in the yz plane, then the value of t must satisfy the equation 0 equals 6 minus 8t. Adding 8t to both sides, we have 8t equals 6. Dividing both sides by 8, we have t equals 6/8, which is 3/4. And now we can use t equals 3/4 to determine the y and z coordinates of the point of intersection. Again, we already know that x of 3/4 is equal to 0. Now we need to find y of 3/4 and z of 3/4. So for y of 3/4, we'd have negative 3 minus 6 times 3/4, which is equal to negative 3 minus, let's write 6 to 6 over 1 times 3/4. Simplifying, common factor of 2, 2 2's and 4, 3 2's and 6. So we have negative 3, or negative 3 over 1. This would be minus 9 halves. Common denominator of 2. So we have negative 6 halves minus 9 halves, which is negative 15 halves, which is our y-coordinate of the point of intersection. And finally, for the z-coordinate, we need to determine z of 3/4, which is negative 2 plus 2 times 3/4. So we have negative 2 plus 2 over 1 times 3/4. Again, simplifying, common factor of 2. We have negative 2 over 1, and this would be plus 3 halves. Again, common denominator of 2. So we have negative 4 halves plus 3 halves, which is negative 1/2. So the z-coordinate is negative 1/2. So the point at which the line intersects the yz plane is the point 0, comma, negative 15 halves, comma, negative 1/2, which once again would be the coordinates of this red point. I hope you found this helpful.